Now, in this session, we will discuss about waveform graph and waveform chart. Open your LabVIEW and come here and click in the new VI. Place it, okay, press Ctrl T. Now here you will find the left one is your front panel. My front panel name is Untitled 18 and block diagram Untitled 18. Right click on the front panel and take a waveform chart and expand the size. Then right click, take a waveform graph and place here and expand the size. You can use waveform graph and chart to display the numeric data. No matter, okay, more than one data, or you have a set of data, you have a data in the form of array, and you want to represent all the data in the form of graph or chart, so you can use the waveform graph and chart. But in the waveform graph, you can see here it's starting with the zero. Sorry, in waveform chart, it's starting with 0 and end time is 100. Okay, but in the waveform graph, you can see here it is equally distributed. Equally distributed, that means now you can see here 0 to 100, the number of equally distributed here, right? These boxes x-axis are equally distributed, but in this waveform chart you will not get that equal distribution. Let's go to the block diagram and try to create a program. Here I am taking a random number generator program. Using this random number generator program, we can generate a random number between 0 to 1, and now here taking a waveform chart, sorry, for loop, and I have given the loop count n is equal to 100. That means loop will run 100 times, and each and every time it will generate one value. And now I am taking the wire outside of the for loop. So this is our auto index tunnel. Due to this auto index tunnel, this program will give a collection of all data in the form of array. Now I am going to connect the array with the waveform chart and waveform graph. Let's come here. Now when I will run the program, so now you can see the program which you can see here, the program is equally distributed, and you will get same replica program, same replicated program. Clear? Same replicated program you can see here. But there is a one problem. And what is the problem there? Both the program and both the display are displaying the same value. The waveform chart is generating value between 0 to 100, and waveform graph is also displaying the value 0 to 100. Here the distribution of x-axis is completely transparent and equal, but the distribution of x-axis is not mentioned on the waveform chart. If I will run the program again, now you can see, now you can determine, or you can examine, or you can see the changes. Look at here, it's again starting the number from 0 to 100, but now it's starting the data, is displaying the data from location number 99 to 199. If I will run the program again, so again it's displaying value from 0 to 100, 0 to 99, but now it's displaying the data 199 to 299. It means if I will run the program again, so it will generate the data, it will display the data from the 190 to 299 location. So what is the important thing here? What I want to explain? I want to explain a wonderful thing, and that thing is the waveform chart has the waveform chart has capability to store the previous data. A waveform chart has capability to display a previous data. that waveform graph don't have. Waveform graph don't have. You can see this scroller button is present in the waveform graph, sorry, chart, and also present in the waveform chart and graph. But this scroll option you will get in the waveform graph only, sorry, chart only, right? So now it is a one difference. Let's go to the another example. Right click, come here, come into the mathematics, elementary, trigonometry, take in, okay, come into the sine and cos function. Right click on the block diagram, come into the mathematics, elementary, trigonometry, sine and cos function, and place here. Create, open the label, come here, divide, copy, wait for a minute. Okay, now the I will update the video on the group so you can watch and you can design. Okay, wait. Now look at here. I have taken the function. Now here I am taking a for loop. For loop, create constant 100. Now here I am taking a while loop. Okay, great. Here I am going to take a waveform graph, waveform chart in the below section, and a waveform graph in the top. After that we'll discuss about your query. Now Control T. Here I am going to connect the waveform graph, so I can connect the waveform graph easily. It's possible? No, not possible. So for that I have to convert it into the indexing. That means using the indexing tunnel you can connect the waveform graph easily with the for while loop. But if I want to connect the waveform chart, okay, but if I want to connect the waveform chart here using the while loop, so easily I can connect. Both are the same in this condition. Let's come inside. If I want to place it inside the waveform chart, inside the while loop, look at it. I can connect the waveform chart. Great. Here also I can connect the waveform chart. So that means we can connect the waveform chart with the individual single number. But I cannot connect the waveform graph with the individual single number. What I want to explain here, waveform graph always take a array data. A waveform graph always take a array data, but waveform chart can display individually single data or data with the proper data with each and every instance. Each and okay, in this program, you know very well each and every iteration, this sine function will generate a value, and we can easily display that data using the waveform chart. If we'll put this waveform chart, so also we can display all this value, but we cannot connect waveform graph with this single value. Whenever the loop will run through, so whatever the data it will generate, each and every data we can display using the waveform chart on the runtime, on the current time, on the data streaming time. So now let's press the Control H. When you will press Control H, so you will get context help, and when you will touch the waveform chart, sorry, waveform graph, So you will get to know waveform graph has xt. You can say it is t0, del t and y array. T0 is a start time. T0 is a start time. Del t is a time difference between 2 points, and y array. Y array store all the data points. But in place of when you will touch the waveform chart, so you will get to know waveform chart is a collection of the okay scalar element, scalar value. You can directly make a cluster or array, and you can insert the data in the waveform chart. If you will, okay, if you want to write a program and run the program continuously, and you want to read the data, you want to write a program and you want to read the data continuously, you want to display each and every iteration data without without uh, means knowing what is the time difference between the 2 points, or the system, or how much time the system is taking to complete the execution. You don't, okay, so you can use the waveform chart. Means if the sampling rate and the time interval is not important for you, so you can use the waveform chart. And if the time intervals is important for you, and you can display the data in a structured manner, so you can use the waveform graph. Waveform graph always take a array data. Waveform chart can take both the data. You can see here. Now please ask your question. If you want to check your previous value on the waveform chart, so you have to right click on the waveform chart, then you click here, and you have to come to the visual item, then you will get the scroller bar, and click the scroller bar. Now using this scroller bar, you will able to find out the this scroll button. Clear? Okay. Here I am going to generate one more array, one more data, and after that here I am coming and I am taking build array functions. We know very well this function can generate sign and cost, two different data. Okay, and using the build array functions, here I am going to create one 2D array using two 1D array, and let's connect the waveform graph. I had connected it with the waveform graph. Okay, I had connected it with the waveform graph. Now same thing I want to do here, but here I have to select a different functions. Here I have to come to the cluster, and I have to take the bundle functions, and take the bundle function and place here. We are going to make a bundle of two different data, and we okay, and then make a connection like this. Now you can see now you can see here, using the waveform chart, we can display the bundle of the two data. Now here I am going to insert a wait time functions, 50 millisecond wait. Run the program. Okay, now you can see two different graphs are continuously running. Now you can see your waveform chart is moving left to right, and you can display each and every generated data. Now, as I mentioned, whenever we use the for loop and while loop, we always have to press the stop button. By pressing the stop button, we can stop our while loop. Now, here I am going to right click. Are you able to see? If you are able to see, then right click on the waveform graph and you will get a stack plot here. So click on the stack plot. When you will click on the stack plot, it will plot your data. It will plot your data, okay, like this. You can run the program easily and you can display each and every data. Now, program stop. Right click here. Right click on the waveform chart. Right click on the waveform chart. Come into the x-axis style. You can also change the all style like this. Okay, you can change it into the equal distribution. Right click, you can change it into the equal distributions here. Now here, right click, come here. Look at here. Here I am taking a bundle. In this bundle, here I am connecting the array, the distribution point. Here I am going to set a distribution point. What is the del t? Del t is time difference between 2 points. And t0, I want to keep t0. I want to keep the t0 start time. Let's try to select here. Okay, it will not work. No issue. Can it will work? No. Okay. I want to give the start time here. Control B. That is a -1. Let's try to give. It's -1. Start time is a -1. Start time is -1 and each and every equal distribution will be 0.5. Okay. Now here I am going to run the program. So now you will see my program has sorry. Now you can see it has been start from the -1 and it is 0. It is 1, 2 and it's going to end on the 4. Means it's taking the complete, okay. In 1 second it's giving you near about 20 data. Why 20 data? Because delta is how much? Delta is 0.05. Delta is 0.05. भाई आराम से, इतना जोर से मत मार, आराम से. रुक जा भाई, आराम से पूरा धूम धूम कर रहा है. It's clear to all of you? If you have any question, then please reply. Yeah. I explained point by point everything. Waveform chart can display the real-time data, each and every instance data, but waveform graph cannot do. As per your question, why waveform chart is present inside the loop? What loop we are using? That is the important question here. Here we are using the while loop, and while loop run continuously. During the runtime, we know very well loop cannot transfer any data outside from inside. That means if I will place all these things like this outside, if I will take all the functions outside, so it will behave like this. Behave like what? It will behave like a, just second, last value. In place of last value, we can change and we can do the indexing. We can change and we can do the indexing. If I will change it and I will do the indexing, okay, so now when the program will stop, at that time it will whatever the data it will generate, we can read only that data. We can read only that amount, that data. Okay, so that is a waste and use okay, that is a waste of our program. Why? Because if you know you want to run your program for 2 minutes, 5 minutes, 10 minutes, okay, so you have to use the waveform graph here. Waveform graph. Why? Because you want to display that specific 5 minute data, 2 minute data. You don't want to measure, you don't want to see each and every second data, each and every second generated data. Suppose if I will run the program, so now you can see we are not getting any data right now. When I will press the stop button, then we will get this data. So what is the use? Okay, that means we are not able to see the current time and run data. Now suppose if I am going to change the program, here I am going to right click, come into the data of, sorry, advanced update mode, and this type sweep kind of data I am going to take here. Okay, sweep kind of data I am going to type here. Just a second. Look at here. Here I am going to write a program. Now you can see one red line is moving from left to right and it's updating the data. I think you have seen this kind of behavior on movie while the doctor is using that ECG machine. We, if you have data in the form of array, so don't worry, you can use waveform graph and waveform chart both to display the data. If you want, okay, and if you want to write a program where your system will generate an array, then don't worry, you can use both the loop for, sorry, both the chart, sorry, both the display setup, display unit, waveform graph and chart. But if you want to display a data in the runtime or in the equation time, okay, and you know your data is coming with a single element, so at that time use waveform chart. If you are aware to know your data will come, okay, with the set of five element, with the set of five elements, so also you can use the waveform chart. Okay, now here I am going to change the program. I'm going to save this program. Okay, I'm not going to save. Let's change the program. One more program. Let's take here. Here I am taking a numeric control. Here I am taking a numeric control. I do take another numeric control. Suppose here I am taking this numeric control oriented slider bar. Okay. Now come here, come into the front panel and come into the waveform chart and take this slider bar. Based on my, okay, based on my distance, distance, based on my distance, it will display the energy. Okay, energy, and let's see, distance multiply with distance multiplied with 2.2.21. It is my coefficient which convert my distance to the energy. Okay, energy lapse. Can I run the program?
Yes.
Okay. Now energy is 0. If I will change something, you will get the data. If I will change one more time, so it will again. So now you can see it is giving you the data. Okay, and it's displaying over each and every second day. Okay, each and every data, and also it's retaining the previous data, the past data, right? Also this function is returning the past data. Let's come here and take a wait functions for 100 millisecond delay. Run the program. Right? Look at here. These are independent numbers. These are independent values. These are independent numbers, right? By using waveform chart, you can display each and every number. You can represent each and every number. Okay. By using this waveform chart, you can display each and every number in a graphical format. That is the power of waveform chart. But you cannot do same kind of practice or same kind of behavior with the waveform graph. Why? Let's see. Suppose, come here. I am trying to take a waveform graph here. Now please tell me, can I connect this waveform graph? Can I connect this waveform graph? Let's try to connect. No, I cannot connect the waveform graph. Why? Because waveform graph takes only array. No matters you have 1D, 2D, 3D, 4D, and number of D array, it will take all your data and it will display. Clear? Now, as I mentioned, waveform graph, as I mentioned, waveform graph contain del t, t0 and y array. That's I'm going to explain right now. Right click, come here. Come into the signal processing, waveform generation and sine waveform. Place it here. Right click. Sorry, create control. Create control. Okay, it's clear to all of you. Now you can easily understand. Suppose what kind of output it will generate. Let's see. Right click, signal output, create indicator. Now you can see in this signal indicator, what is it? Del T. What is it? Del T. What is time difference? 0.0 m. 1.0 m. 1.0 m. And we are getting how many data? We are getting some data. Look at here. Del T, T0, del T and Y array. Output is what kind of output is here? T0, del t and y array. T0 is start timing, del t is that okay, interval between 2 points, and y array contain the data. Here I am going to take a indicator, waveform graph indicator. Now this waveform graph, look at here, it's displaying the data. Again, are you able to see the sampling rate? Now create control. If you will see the sampling rate, in this sampling rate, the number of sample, this sampling rate, just a second, why I'm not able to control it. In this sampling rate, okay, the sampling rate is 100, and sampling rate is 1 kilohertz, and number of sample is also of 1 kilohertz. Suppose if I will put a sample rate is equal to 2 kilo, so now it will 2 kilo, okay, number of sample 2 kilo. Suppose if I will take it 5,000, are you able to see the changes? First we get one signal complete, then we get second signal, third signal, fourth signal, fifth signal, right? Now suppose here it is 1 kilohertz, 1 kilo sample, sampling rate and number of sample is 1 hertz. Suppose it is 5 kilo sample, 500, so we will get the half signal. Suppose it is 100 sample, we will get only 100 sample. Suppose here if I will write a 10 sample, and here the sampling rate is 100, so how I will get? Look at here, are you able to see? Suppose the sample and sampling rate both are 10. Suppose the sample and sampling rate both are 10. We are getting the sine wave like this. Are you able to understand? Suppose both are 20. Suppose both are 20. We will get a better smooth signal if the number of sample will increase. Whenever the number of sample will increase, you will get a smooth signal. A smooth signal. Okay. Either you can put two sample, you can put the two sample, and also you can measure the maximum length, okay, either you can measure, look at here, the 0 and max is 1.5. Are you able to see this one? Okay, run. You can see here 0 and 1, what I had given here, I am taking two sample, still we are getting the maximum amplitude. Suppose if I will give the three sample, now still I am getting the maximum, sorry, okay, amplitude, still I'm getting the maximum amplitude. Now suppose it is 100 sample, and here sampling rate is 100 and sample is 100, we are getting this data. Suppose here I am taking the 10 sample, the sampling rate is 10 and number of sample is also a 10, you will get an array, stop, right. So suppose here I am taking, why? Because at least we need to take the sampling rate 20 times, run. Look at here, we are getting the 10 samples, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is the time difference? Can you tell me, sir? What is del t right now? Del t is zero point 0 millisecond. Sorry, del t is 0.5. Del t is, yes, 50 millisecond. Del t is 50 millisecond. Okay, why? Because if you will see here, in between 1 second. In between 1 second, it is 50 millisecond, and we are getting the data. Are you getting, sir? Rishikesh, sir? Now, this is a waveform, and if you'll take the get waveform component, here I am going to fix it. I'm going to fix it 1000. Also, I'm going to fix it the 1000. It is get waveform component. When you will connect the get waveform component and you will drag, so you will get attributes. You can, by clicking del t, t0 and y array, you can select. Del t will give you the time. Del t will give you the time. Look at here. Del t will give you the start time. Sorry, t0 will give you the start time. Del t will give you the time difference between 2 point, and y array will give you the information about your the data who are creating the waveform graph. Suppose, look at here, I am taking one more waveform graph. Here I am taking one more waveform graph, and if I will connect it, still I will get the same data. Are you able to see? But there is only one difference. You can see here. Here we can see it displaying the same data, but the distribution is 0 to 1000. X-axis number. Distribution is 0 to 1000, but here 0 to 1 second. Here is showing the second and is showing the number of data. Are you able to see, sir? Any question? Everywhere, whenever you want to analysis the signal, or uh, yes, you want to record, at that time it will be useful. How many sample you want to acquire, what should be the maximum sampling rate, okay, what should be the maximum sampling rate which is required to us. As like, look at here. Here I am keeping the maximum frequency is 10 for the signal, and the sampling maximum frequency is 10 for the signal. Okay, frequency is maximum frequency is 10 for the signal. Sampling rate is 1 kilohertz, and number of sample is 1000. So we are getting this data. If I will reduce the number of samples, so we will get the data. Why? Because the time difference is fixed. The time difference is fixed 0.1. What is the meaning of time difference? The frequency rate, the sampling rate, 1 by sampling rate, and sampling rate is 1 kilohertz. Sampling rate is what? 1 kilohertz. If I will get 1 by the sampling rate, and what is the sampling rate? Sampling rate is 1 kilohertz. Sampling rate is 1 kilohertz. That's why delta is 0.001. Are you able to understand both this? Just because the sampling rate is 1 kilohertz, that's why the delta is 0.001. 0.001. Now you can see the distribution is 0.001 is the same. The distribution 0.001 is same. So we are getting the only tenth. Okay, we are getting the only the okay. What can I say? The tenth. Okay, 1 by 10th data. Okay, 1 by 10th data. If I will use a waveform chart here, so I think you will able to understand it better. Let's take a waveform chart. Let's take a waveform chart, and I will try to make you understand. Okay, now suppose the sampling rate here, the sampling rate is 10. Sorry, here the frequency is 10, sampling rate is 1 kilohertz, and number of sample is 1000. That means here our data should be distributed with the 0.001 second. Data should be distributed in between 0.001 second, right? Now run the program. You can see here, the distribution of this data. You can see here the distribution of this data is here only. Here I am going to change it and I am going to give it the 1. Suppose are you able to see the signal? We are getting this signal within a 1 second only. Now here I am going to reduce the sample is equal to, because here frequency is 1 which I have given, that's why we are getting this data. Now you can see, now I reduce the sample just about the 10 times, so we are getting the smallest portion of the data, because we are taking the 100 sample, 900 sample we are not taking. Clear? Suppose if I will
Yes.
suppose if I will take 10 sample, so we now you can see we are taking only the 10 sample, only the 10 sample. 990 sample we are not taking, we are not reading. It's clear? So using this you can increase the, and you can analyze your signal. Okay, suppose here I am going to read the 1000 samples. So in the 1000 sample you will find the data with the very thick, and you will get the immense number of the informations. Look at here, how much information you can collect, how much. Okay, smooth data, if you will increase now, so smoothness you cannot say. Let's see if you will try to check the, just a second. uh no. Okay, look at here, can I zoom it? I am going to zoom this location. Are you getting the data? Now you can see if I want to zoom more, so I can zoom more. Now even, so now you can see, okay, how smooth you are getting the data, how maximum number of information you are collecting. Now if the number of sample is high, that means you are collecting the high precise data. Okay, other will discuss tomorrow. Go and enjoy your time and be prepared for tonight's that IPL match. I will share this video on WhatsApp group soon. You can watch and you can practice.
Thank you, sir.